Hi friends, welcome to the Smart Crack series for NEET 2022. So in this series, what we are going to do is, we are going to pick simple concept from each chapter of your NCERT physics book, and we are going to solve some problems based upon that concept which have been asked repeatedly in the NEET exam. So let's begin. Our today's concept is error analysis. This is very simple concept, so please pay attention. So let's suppose I want to measure some quantity. So let's suppose I want to measure length of this pen, and so I take a meter scale and I go on measuring length of this pen. Let's say for n times. I take n measurements. So suppose the measured values are L1, L2, so on and so forth up to Ln. These are n measured values for length of this pen. Okay. So now in case that I don't know what is the actual value of the length of this pen, how do I find the value which is close to the actual value? So what do I do is I take the average. Okay. So I find out mean value of this quantity, mean value of the quantity. Let's call it Lm, and it's just equal to what? L1 plus L2 plus so on and so forth up to plus Ln divided by number of measurements, which is n in this case. Okay, so now I can find out the possible error in each of these measurements. And how do I do that? So error is the difference between the measured value and the actual value, so which in this case is the mean value. So error delta L is equal to what? Let's say L is the measured value, so it is L minus Lm. Okay, so now we can write down errors in all these measurements. So error in first measurement is suppose delta L1, it's equal to what? L1 minus Lm. Error in the second measurement is delta L2, is suppose L2 minus the mean value, so on and so forth up to delta Ln, because nth measurement is the last measurement. So delta Ln equals to Ln minus Lm. Alright, so this is how we find out error in all the measurements. Now let's suppose I want to find out the mean error in this quantity. So how do I do that? So I will find out the mean absolute error and not the mean error. Okay, and why is that? It's because sometimes the error would be positive and sometimes it would be negative, and there are great chances that if you add all errors, positive and negative, that you will end up getting 0. Okay, so which indicates that the mean error would be 0. That's not the case. Okay, so it doesn't matter whether error is positive or error is negative, the error is error. And that's why what do is we find out mean absolute value of the error instead of the mean value. Okay, so how do we find that? So let's suppose the mean absolute error is delta Lm. It's equal to sum of all the absolute errors. So delta L1 is absolute error in first measurement, delta L2 is the absolute error in the second measurement. So we add them all up to what? Delta L n, and again we divide by the number of measurements. So this is how we find out the mean absolute error. Okay, and after that there are two more quantities. So one is called the relative error. Okay, and it's just equal to the mean absolute error divided by the mean value of the quantity. Okay, and then next term is the percentage error, and it is just relative error multiplied by 100. Okay, so we find out the percentage of the error. So delta Lm upon Lm multiplied by 100. Okay, so this is how we figure out how much would be the error. Okay, how much is the error in any measurement. All right. So now next thing that we need to know is how these errors get added up in addition, multiplication, subtraction and division. Okay, addition, subtraction, division and multiplication. So let's find out that. So let's see what happens to the error in addition of two quantities or subtraction of two quantities. Okay, so let's suppose I have C equals to A plus B. Okay, so now let's suppose delta A is the error in A. So the measured value of A will be somewhere in between A plus minus error in A, which is delta A. And the measured value of B would be B plus minus delta B, somewhere in between B plus and minus delta B. And let's suppose the measured value of C is somewhere in between what? C plus minus delta C. What are these? These are the measured values. Okay, so that means there is error delta A in A, delta B in B, and what we have to find out is what would be delta C in terms of delta A and delta B. Okay, so when we add two quantities, what happens is the error in these two quantities are added up to get the error in the resultant quantity. Okay, so delta C is just equal to what? Delta A plus delta B. All right, and even if we have a subtraction, okay, so when we subtract a quantity from another quantity to get some resultant, so suppose C equals to A minus B, so what happens in this case is also the errors are added. Okay, so delta C is equal to delta A plus delta B, and this is because we are interested in finding out the maximum possible error in the resultant. Okay, so we don't do delta A minus delta B. What we do is we add the errors. Okay, we are interested in the maximum possible error. So this is error in addition and subtraction. What happens? The absolute errors in the two quantities, they get added to get the absolute error in the resultant. All right, so now let's talk about multiplication and division. So let's suppose now C is equal to A times B. So in this case, what happens to the error? So let's suppose delta A upon A is the relative error in A, delta B upon B is relative error in B. So what happens in this case is delta C upon C is equal to delta A upon A plus delta B upon B. Okay, so we are not going to see the derivation here. The concept is important. What happens? The relative errors get added up to get the relative error in the resultant. Okay, so relative error in these two quantities which we are multiplying, they get added up to get the relative error in the resultant. So this happens for multiplication. What about division? Same happens for division also. So if we have C equals to A upon B, so delta C divided by C is equal to delta A upon A plus delta B divided by B. So in case of product or a division, what happens? Relative errors in quantities get added to get relative error in the resultant. All right. So now we need to know one more piece of thing to be able to solve the problems. Okay. Now let's suppose C is equal to A square. Okay, so this a square can be written as a times a, and we can write from what we know till now that delta c divided by c is equal to delta a upon a plus delta a upon a. Okay, because what happens to the error, relative error in multiplication, it gets added. Okay, so it is 2 times of delta a upon a. So this is 2 times of delta a upon a. Now you can guess what will happen if we have c equals to a cube. So what happens is delta c upon c is just equal to 3 times. Okay, in case of square it is 2 times, in case of cube it is 3 times of delta a upon a. And now you can easily guess what will happen if c is equal to a raised to n. So what happens is delta c divided by c will be equal to what? That power n times of delta a upon a. And now we'll add up all the pieces of theory that we learned till now. So let's suppose p is equal to a raised to x, b raised to y divided by c raised to z. Okay, so what will be the relative error in p? So it's very simple. The relative error in p just equal to x times the relative error in a plus y times the relative error in b plus z times the relative error in c. All right, and what about the percentage error? So percentage error is just relative error multiplied by 100. So percentage error in p will be equal to what? X times the percentage error in a plus y times the percentage error in b plus z times the percentage error in c. All right, so this is all we need to know in the theory of error analysis to be able to solve the problems. So let's try to solve some problems. So the first problem is, if the error in the measurement of radius of a sphere is 2%, then the error in the determination of volume of the sphere will be how much? So it's very simple. We know how the volume depends on the radius. So volume is equal to what? Volume of the sphere is 4 by 3 pi r cube. So it is some constant multiplied by r raised to 3. Okay. So now the percentage error in r is given. So the percentage error in v will be equal to what? Because it is r raised to 3. Okay. The power of r is 3. It is 3 times the percentage error in r. Okay, so simple. So it is 3 times of how much? 2%, and that's equal to what? 3 times of 2 is 6. So it is 6%. So option D is the answer. All right. Next, again, it's similar problem. In an experiment, 4 quantities A, B, C, and D are measured with percentage error 1%, 2%, 3%, and 4% respectively. Quantity P is calculated as follows. So P, the formula for P is given. It is A raised to 3, B raised to 2 divided by C, D. Okay. The percentage error in P is, it's again very simple. It's the similar problem, and this kind of problems get repeated many times. Okay. So we know P is equal to this. So we can write down that delta P upon P into 100, this is percentage error in P, it's equal to, it is A to the power 3. Okay, and that's why it should be 3 times of the percentage error in A, which is delta A upon A into 100 plus, it is B raised to 2 here. So it is 2 times of the percentage error in B, delta B upon B into 100, plus it is divided by CD. So delta C upon C into 100, because power of C is 1, plus delta D upon D into 100. Okay, because power of D is also 1. Okay, so now it's very simple. We just have to substitute the values. So it is 3 times of delta A upon A into 100. It's 1%. Okay, so 3 times of 1% plus 2 times of how much? 2%. So 2 times of 2% plus 3 times, sorry, not 3 times, 1 times only of the percentage error in C, which is 1 into 3%, plus the percentage error in D, okay, which is how much? It's 4%. So 1 into 4%. So add it all up. So 3 times of 1 is 3, 2 times of 2 is 4, so 4 plus 3 is 7, 7 plus 3 is 10, and 10 plus 4 is 14. So what is the answer? Answer is 14%. Okay, option C is the answer. Alright, so you got it? It's very simple. Let's see another problem. And again, it's very simple, very similar, and it has been asked recently in NEET 2019. So in an experiment, the percentage of error occurred in measurement of physical quantities A, B, C, and D are 1%, 2%, 3%, and 4% respectively. Then the maximum percentage error in the measurement X will be. Okay. Again, the formula for X is given. So percentage error in X will be equal to what? Because it is A raised to 2. So it is 2 times of percentage error in A. I will write delta A upon A into 100, plus, because there is B raised to half, so we have half times delta B upon B into 100, plus it's in denominator C raised to 1/3, so it is 1 by 3 times delta C upon C into 100, and plus we have D raised to 3. Okay, so it is 3 times delta D upon D into 100. Alright, and now let's again substitute the values. So we have 2 times of percentage error in A is 1%, so 2 times of 1%, plus we have half multiplied by percentage error in B, which is 2%. So half times 2% plus 1/3 of how much? 1/3 of 3%. So 1 by 3 times 3. Okay, and plus we have D raised to 3, so 3 times of 4%. Okay, so what do we get? So 2 times of 1 is 2. Okay, so 2 plus 2 by 2 is 1, so 2 plus this 1 is 3, and 3 by 3 is again 1, so 2 plus 1 plus 1, 4, and 3 times 4 is how much? 12. So 12 plus 4 is 16. So answer is 16%, right? So this is the answer. Alright, so you got my point. These kind of problems are repeated very often in the NEET exam, and that's why this is an important topic. Okay, so please try to solve some more problems based upon error analysis. This is all for this video. See you in the next video. Thanks for watching.